the air, and the magic of radio broadcasting brings music and laughter into millions of homes. The simple twist of a dial brings you sparkling comedy or thrilling drama, the march of the headlines, or the immortal music of the ages. Behind that magic dial is the wonder that detects and amplifies the radio waves. It consists of a highly evacuous or metal emerald, which of electricity called electrons. A plate which attracts the electrons, and one or more grids which control the flow of electrons. A heater coil within the cathode heats the cathode. Electrons are released and flow to the plate. The grid acts as a valve, instantaneously controlling the flow of the electrons from cathode to plate and thence into an external circuit where the electrons are put to work. This unique controlling action makes it possible for your radio set to receive, amplify, and reproduce faithfully your favorite broadcast programs. In the manufacture of vacuum tubes here in the RCA plant, raw materials are scrupulously tested from the very beginning. Chemical tests ensure the highest quality and purity of all substances used in the making of vacuum tubes. The engineer, too, helps to control the quality of raw materials. This is a test of tensile strength. The skilled physicist also does his part. Purest powdered tungsten and molybdenum must be formed into rods before being drawn into wire to make the heater coil. Softened and hammered under intense white heat, each rod is then annealed and drawn into a wire the size of a human hair or smaller. In the manufacture of RCA metal tubes, an important step is the winding of the grids. This machine winds fine wire around two parallel strands of heavier wire at exactly spaced intervals, producing a grid that resembles a tiny ladder. Many different types of grids are required in all the varieties of modern vacuum tubes, so other machines make them in other shapes. The fine wire for the heaters is automatically cut into required length and fed into this ingenious machine, which coils them with unfailing accuracy. Then the heater coils are sprayed with many coats of quick-drying alumina insulating material. This coating must be perfectly uniform and of the proper thickness, so the heater will give faultless performance. Manufacture of the plate or anode, which is to collect the electrons, begins when a strip of metal is coated evenly with carbon black in a special furnace. The carbonized strip, as it is now called, is shaped on dies to make the plate. Because variation in size must be less than the thickness of a sheet of tissue paper, the plate is micrometer inspected. In this machine is made the cathode, heart of the vacuum tube. The cathode is hollow, designed to hold the heater coil snugly. A tab is welded to the end of the cathode to make a connection in the finished tube. This is how it looks. Then they are sprayed with an active material which will provide the electrons. The dry cathodes are weighed on a precision scale to be sure they are coated with the correct amount of electron-emitting material. Here, a tiny device is made and coated with a chemical called the getter, which later will be used to complete the exhausting of the gases from the finished vacuum tube. Important parts of the metal radio tube are the header and a collar upon which the stem will be built. First, however, they are welded together into one solid piece. A long glass tube through which air will be exhausted from the assembled metal tube is inserted in the header, and a large hollow glass bead is added. Lead wires are fed into the machine from the top and dropped through a funnel-like device into the header. Now the assembled parts rotate through a series of flames. The glass bead softens, and the plastic glass runs around the wires, sealing the tiny openings, fusing all the parts into one airtight piece, the stem of the metal tube. Through this device called a pyrometer, an operator checks the temperature of the hot glass to ensure the formation of the proper airtight fusion of the glass and the metal. The stem is then allowed to anneal by cooling gradually. The completed stem is tested in a device called a polariscope, which projects a pattern of the glass strains on a screen and shows at a glance that the stem is properly made. In another machine, the short, straight ends of the lead wires are bent into the proper shape for assembly. The next step in assembling the metal tube is to mount the grids, beginning with the smallest one. Several different grids are used. The number depends on the type of tube. Next, the cathode is inserted. The plate or anode is slipped on, a mica spacer is added, and the rods of the grids are fitted into holes in the mica to support and insulate the parts. The insulated heater coil is inserted in the cathode. Support rods are placed in position and welded. The completed cage is then added to the stem, and its connections are firmly welded. The tiny getter is put in position and welded. A top collar is added to hold the cage to the stem. The metal envelope is slipped on together with the ring known as the header skirt. Now the metal tube is welded and sealed into one airtight piece by an electrical current of 50,000 amperes. The assembled tube is next connected to an exhaust manifold. Then the tube is heated by a gas flame. The air within is exhausted by a pump through the exhaust tube. The getter is flashed electrically to absorb the remaining gases, and the exhaust tube is then sealed off by a tipping off torch. The metal tube is now ready for the addition of the base. Let's leave metal tubes for a minute. When a tube has an envelope of glass instead of metal, the assembly and exhausting process are somewhat different. The envelope is fused to the stem, and on the same machine, the gas is drawn out of the tube. Inside the tube, the getter is flashed by induction and absorbs most of the remaining gases, creating a very high vacuum. Now back to our metal tubes. Lead wires are threaded into the base, each wire fitting into the correct pin. The lead wires are trimmed to correct length and soldered by dipping the ends of the pins into molten metal. Like wooden soldiers, metal tubes march in single file to receive a coating of paint. Now dry, the tubes are tested to be sure there is no electrical leakage, and in the same operation, the base is crimped on tightly and the metal tube is ready for aging and tests. After the tubes have been on these aging racks, the long cycle of meticulous quality control that began with the rigid testing of raw materials nears its end as the completed tubes are thoroughly checked and accurately tested to ensure that they will give flawless performance in your radio set. Without their big brothers, the giant power tubes in the broadcasting studios, the best receiving tubes in the world could bring you no reception. Many varieties and sizes of power tubes are required for many different purposes. Made on the same principles as the smaller tubes, the big ones are similarly assembled. Grids and cathodes, heaters and plates, stems and cages, often many times larger than those used in receiving tubes, are put together with infinite care. Skillful workmanship ensures that these tubes will send you music, news, comedy, and drama without interruption. For in radio, as in the theater, the show must go on. The power tubes are exhausted of gases and sealed off. Again, the most rigid testing with apparatus of utmost scientific accuracy is necessary to ensure perfect performance of tubes that must not fail. They must not fail because it is not only the radio amusement of a people that depends on them. Human life itself often hangs upon the performance of the tubes you see now being tested. The safety of ships at sea, of the lives of flyers and their passengers, the health of a nation, the protection of your community from crimes and violence, the education of our children, the advancement of science. All these and many others are important services of the vacuum tube. In public address systems, the vacuum tube makes it possible for all to hear. In schools, they bring lectures and announcements to all classrooms. Tubes amplify music for dancing and sports announcements. Great airports would be crippled without the vacuum tube. And airliners ride the radio beam the tube makes possible. Vacuum tubes gave voice to silent pictures. Adding to the pleasure of millions and bringing knowledge from the far corners of the earth to the classroom. Radio began at sea, saving life. Since then it has become vital in peace and in war. Radio is playing a major part in the relentless war against crime, guiding the vigilant police, directing them to the criminals they seek. In fighting fire, in safeguarding our natural resources, the vacuum tube is invaluable. The forest ranger in his plane directs firefighters on the ground. Sent high into the atmosphere, sensitive shortwave devices make possible long-range weather forecasts, vital for commerce and for navigator of air and sea. When calamity strikes, it is by radio that aid is summoned. Though regular communications are crippled, the amateur radio operators, the heroic hams, still bring aid with the help of the sensitive vacuum tube, bring serum from the sky to save human life. Helping to safeguard the nation's health is the electrocardiograph, detecting heart ailments, giving the doctor a written record, enabling him to see as well as hear the beat of the human heart. And in television, yesterday the dream of the scientist, today a living, working reality. Tomorrow bringing entertainment to millions, bringing music, drama, action from a central studio into their very homes. As so many other uses besides entertainment have been developed out of radio by the RCA laboratories, so will others come from television. One is already here, the electron microscope, opening to scientists new worlds that men have never seen before. Making possible achievements of which once they had only dreamed, magnifying specimens as much as 100,000 diameters.